Mackie 6-band EQ. The Mackie folder of the new filters list contains mono and stereo parametric equalizer plugs, which are identical except the stereo version processes 2 channels instead of 1, and both use a graphic display to indicate the current EQ settings. Each of the 6 bands is represented by a yellow circle on the graph with the number of the band inside it. These points can be dragged with the mouse to change the EQ settings. For example, I can set up a low shelving boost by clicking on node number 1 and dragging it upwards, while dragging left or right will change the shelving frequency. Doing the same for band 6 will create a high shelving boost or cut, while bands 2 to 5 default to peaking types and can be used to cut or boost specific frequencies. Peaking bands can also have their Q values adjusted by right-clicking the node and dragging left or right, and this will adjust the slope of the bell curve to control the amount by which adjacent frequencies are affected. Possible Q values range from 0.1 to 16, which is a very wide range indeed, and most of the time you will not need to set the Q anywhere near the extremes. 0.7 is a good choice if you want a transparent and natural sounding EQ boost, while values of around 1.4 are useful for notching out problem frequencies. The parameter values can also be adjusted by clicking on them directly and dragging up or down. And this lower section also provides an active switch for each band and a choice of EQ types. Band 1 is set to low shelving mode by default, but it can be changed to work as a peaking band instead, or to function as a simple high-pass filter. Likewise, band 6 defaults to a high shelving type, but can be switched to a peaking type or to a simple low-pass filter. Bands 2 to 5 can all be switched to shelf slopes instead, in which case bands 2 and 3 will become low shelves, while bands 4 and 5 become high shelves. When EQing individual channels within a mix, I usually like to start with the channel soloed. A common technique is to high-pass filter all channels except those that need to dominate the bass end of the mix. So unless I am processing the kick drum or the bass guitar, I will usually start by switching band 1 to high-pass mode and increasing the frequency until I start to hear it working, and then back it off a bit. Of course, you will be able to set this filter much higher for a hi-hat part or for a female vocal than you will for a male vocal or a guitar part. But if you are mixing on small near-field monitors, this might remove low-frequency rubbish that you are not even aware of. My next step will depend on the recording. If I can hear flaws in the recording, perhaps from a bad choice of microphone or position, then I will try to address these problems by cutting or boosting mid-range frequencies. A harsh or brittle sound is often an indication that some upper mid frequencies are too prominent, while a boxy or nasal sound may indicate too much low mid. The standard technique is to dial up a healthy EQ boost, then sweep that boost around the suspect frequency range until you hear the nasty frequency leap out at you. Then you cut that frequency back and adjust the Q to make sure you only notch out as much as you need. When I am happy that the part sounds as it should on its own, I will then go fishing for other important frequencies. The technique for this is the same as before, except now instead of ugly frequencies, I am hunting for any frequency that seems important. For example, a snare drum may have its main note centered around 200 Hz, while the crack from the snares lives around 3 kHz. Each time I find an important frequency, I will turn that band off before hunting for another, as I will always make the final decision in context with the rest of the mix. A good mix should fit together like a jigsaw puzzle, and it is frequently necessary to notch out a frequency in one instrument in order to allow another to be heard properly. For example, it is common practice to cut the low mid-range back on the bass drum in order to leave room in that region for the bass guitar. Once I have found some important frequencies for that part, I will therefore always unsolo the channel so I can hear the effects that cutting or boosting them has on the rest of the mix. If you need to boost the bass with a shelving band, try setting a peaking band slightly higher with a small cut. This often sounds more transparent than a simple low shelving boost. Likewise, if you find you need to boost the high frequencies, try cutting slightly lower down with a peaking band. Alternatively, you can approximate a Baxendale type of curve by setting a peaking band to the lowest or highest frequency possible, and then using the Q control to determine how far up or down the spectrum to boost or cut. The graphic display is very useful to show the EQ settings at a glance, and also to explain the different types of EQ. But I would urge you not to pay too much attention to it while EQing sounds to fit into a mix. Otherwise, it is easy to find yourself adjusting the EQ to make it look nicer rather than to make it sound better.